Welcome to Energy Talks, a regular podcast series featuring expert discussions on power system testing, data management, cybersecurity, and important trends in the power industry. My name is Scott Williams from the podcast team at OMICRON, and I will be your host. Hello, ladies and gentlemen, and welcome aboard today's power system testing session. Before we take off, we want to give you important safety information to ensure that your tests are as safe and comfortable as possible. Please keep your safety belt fastened for the duration of the test and place your test set in an upright position. In the unlikely event of an evacuation, please remain calm and follow the illuminated path along the floor to the nearest emergency exit. If the substation floods, you can find a life vest underneath your test set. Pull the life vest over your head, fasten the belt around your waist, and pull the red tag to inflate it. Thank you for flying with us today. Wouldn't it be nice if all power system engineers received the same safety reminders as passengers on a plane before each test? Fun aside, ensuring maximum safety in a real substation is nothing to joke about. Working with electricity is always dangerous, especially when dealing with high-voltage electrical equipment, where every test can be a matter of life or death. Electrical engineers must depend upon their vigilance, strict adherence to electrical engineering safety rules, and even the safety features in their testing equipment to ensure maximum safety when working around electrical power. In this episode, we speak with Jacob Hanela, Safety Product Manager at OMICRON. He will discuss power system testing safety in high-voltage environments and how life-saving features are engineered into and continuously optimized in testing equipment. So without further delay, welcome, Jacob, to this episode of Energy Talks.
Thank you for having me.
Jacob, to what extent does the topic of safety play a different role for electrical engineers?
Well, of course, safety is important in all professions. What is so special about electrical engineers, and especially when working in the high voltage range, is the level of risk. The danger is not recognizable with the human senses. You can't see electricity, you can't hear it, and you can't smell it, and yet it's life-threatening. Depending on the voltage level, an accident will have immediate catastrophic consequences. This requires a high degree of focus at work. As a test device manufacturer, we can provide support with safety features in hardware and software. However, only your own caution and strict adherence to the 5 safety rules of electrical engineering can reliably ensure that life-threatening situations are avoided.
Jacob, just for all of our listeners who may not be familiar with them, can you please remind us of what the 5 safety rules are?
Sure. So first, disconnect completely. Second, secure against reconnection. Third, verify that the installation is dead. 4, carry out grounding and short-circuiting. 5, provide protection against adjacent live parts. And obviously, it's also vital to carry out these steps in the correct order.
Thank you for that overview, Jacob. So even when these safety rules are followed, things can still go wrong. And you alluded to a few important aspects to also consider. Could you describe why more than these safety rules may be needed when working in high-voltage power environments?
Well, additionally, there are local requirements. And I would also definitely recommend to bring along a colleague so you're not alone in the substation when you perform the tests. Try to start rested. Try to be well prepared and focused. Of course, many devices have built-in safety features. You can find more about them via the user manual.
Very good. So you mentioned these life-saving safety features that are built into testing devices. At OMICRON, what is your role in this area, and what is your responsibility?
As a product manager, I'm taking care of OMICRON safety accessories, and I support the general device safety features. During my professional life, I have learned that safety is a remarkably diverse topic, and it's also more interesting than one would think. There are, of course, legal requirements that need to be complied with. There are plenty, and they vary around the world. Fortunately, we have specialists in the company that support me with that. However, there is also the application side of things, our expertise and experience that we as OMICRON can bring in to make the product not only safe from a legal point of view, but also when used in a substation environment. Both aspects need to be considered from the very start of the product idea. I have gained a fair share of international field experience and have an educational background in product development. I try to bring my own and my colleagues' expertise together to develop the best and also safest product.
Very interesting, Jacob. Thank you. So what role does safety play in OMICRON's product development?
Safety is very important in developing a new product. All of our products need to comply with basic rules, like, for example, the CE, of course. But OMICRON already has many products that are additionally certified to carry the famous TÜV Octagon seal, which is voluntary in most countries, but ensures an external point of view. So you could say there's another pair of expert eyes taking a look at it. But that's not enough for us. This only ensures that the status quo of the safety requirements is met. But we want to continuously improve the safety of the devices. We ask ourselves every day, how could we save lives? With the PSRA, the Product Safety Risk Assessment, a process for assessing product safety is part of every product development.
That's interesting. Can you explain how a PSRA process works?
So the PSRA, the Product Safety Risk Assessment, is a type of FMEA, a failure mode and effect analysis. It's a defined and structured process for identification and evaluation of risks. It's used to eliminate or reduce risk to a tolerable level. This is done really in all life cycles and using a step-by-step approach. First, the failure modes are identified and reported. This can be done by every employee working for OMICRON. Everyone can contribute to the safety of our products. The risk is then assessed by a multi-domain expert team. All identified risk must be reduced to an acceptable level by implementing risk mitigations. We are using the ALARP principle, as low as reasonably practical. And the PSRA is a living process which accompanies the product until the product is withdrawn from the market.
Very good. Well, thank you for that clarification. Do you have any specific examples of the results of a PSRA?
Yeah. In one case, the development team, together with the applications team, identified possible missing or wrong connections during a measurement of a substation asset. If the wiring error could lead to a substantial risk for the user, mitigations need to be found. This is why many of our products have an automatic wiring check and quite detailed circuit diagrams in our software interfaces. In other cases, we have had a colleague from production team who detected a defect internal connection during the quality assurance process. The problem was fixed immediately for the affected unit, but it was also reported and evaluated in the PSRA process. Fortunately, in this case, the connection was not safety critical due to other measures that were already introduced during the product design. Nevertheless, we have added additional quality checks to ensure this never happens again.
Well, it sounds like the smallest details matter when it comes to safety and saving lives.
Yeah, they really do. It's remarkable how much effort is put into finding the optimum position for emergency switching off button, for example, or how to develop the perfect acoustic warning signal for some of our devices. Think about the safety accessory SA2 with the emergency switching off button, the red and green signal light, and the beeper. The frequency range of the audible signal is, of course, important to ensure audibility, even within a loud ambient noise. It should be clearly recognizable as dangerous, also by non-professionals. It should be loud, but it should not be deafening. Luckily, there are some standards that give excellent guidance on this topic.
Well, since so much work went into developing this signal, let's give it a quick listen.
That's annoying, right? Well, it really should be. But no worries, the beeper can be deactivated if you work in a quiet environment, like, for example, an office. But they are a great benefit if you're working in a substation and especially if there are other parties around.
Well, that would certainly get my attention, so it meets the aim of alerting the user and focusing on a potentially unsafe situation. It's exciting how many things come together regarding safety in the product development, but when a product is finally launched on the market, is your work finished?
No. Even after launching a product, our quest for greater safety continues. A PSRA will be conducted as soon as a new potential is detected. But there is more. Last year, we released a software update for Primary Test Manager, also known as PTM. In the version 5.0, the CPC100 received two new features called first the 2kV timeout in quick, and second the rapid fault sense, RFS. The 2kV timeout is easily explained. In the CPC quick mode, it stops the high voltage injection after user-definable time. RFS, on the other hand, is an output supervisor that is active in some output modes. As a statistical method, it requires a few stable signal periods, typically a few seconds, to become active. But when active, it can detect output changes and initiate an immediate switch off of the CPC100. But caution, these features are a valuable addition to existing safety features, measures and rules, but they do not replace them. They are only active under certain conditions. Our greatest goal must always be to prevent accidents in the first place. And that's why the existing safety measures like the 5 safety rules must always be followed. But what is great about these features, they are even applied to your first CPC purchase because both functions are fully backward compatible and they are also free of charge.
Very good. So in terms of safety features available in a particular testing device, how does that affect when somebody selects a device, their consideration process?
I think that if a new device is selected, there are many things to look at. And from my point of view, the safety features and also perhaps the trust in the manufacturer should be a great part of the evaluation.
So apart from these obvious safety features that you told me about, are there other aspects that influence the safety of Omicron devices?
Yeah, the product quality. So Omicron devices are really used worldwide, and that they're used every day. They must work reliably in various environments. So from the Middle East, also to Alaska or in Norway. They are also used offshore, where reliability is really the king. Before the shipment to the customer, our devices are thoroughly checked, also in a temperature chamber during the so-called run-in test, just to ensure that they work well even under rough conditions.
So what factors or trends drive Omicron's continuous development of product user safety features? This process seems never to end.
Yeah, I agree. And the awareness for safety is also constantly growing at our customer side. Due to the expansion of the power grid and the demographic shift, there are many newcomers in the field, maybe with less experience, and they still need to perform tests. Those that are experienced have a lot on their mind, not just the measurement itself, and that means that distraction is a major concern. The instrument can support indirectly by being simple and safe to use and offering guidance throughout the measurement process. Using safe testing method is another strong advantage. Users can be sure that we are constantly developing new practical safety features to make our tests as simple, efficient, and safe as possible.
Jacob, can you give us an example of what is currently in development and what users can look forward to soon?
Well, it's unlikely that our test sets will come with live vests anytime soon. The same goes for airbags, safety belts, and anti-roll bars. However, you can be sure that we are constantly developing new practical safety features that aim to make your test as simple, efficient, and safe as possible.
Great. Thank you, Jacob. Well, if you want to be among the first to hear about the upcoming safety features, I invite our listeners to follow us on LinkedIn. You can also regularly read news about the world of Omicron on our website at OMICRONenergy.com. And of course, we would be happy if you listen to upcoming Energy Talks episodes about safety.
Sure, and don't forget the OMICRON magazine that reports on this topic sometimes.
Very good point. Jacob, thank you for joining me for this episode of Energy Talks.
Thank you so much for having me, and stay safe.
Good advice. Thank you, Jacob.
Thank you.
And a big thank you to our audience for listening to this and other episodes of Energy Talks. We always welcome your questions and feedback. Please send us an email to podcast@omicronenergy.com. OMICRON has several years of experience in power system testing, data management, and cybersecurity, and offers a matching solution for your application. For more information, visit our website at OMICRONenergy.com. Please join us for the next episode of Energy Talks. Goodbye for now, everyone.